Okay, all good.
Okay. Hello everybody. Good morning if you are in the Americas, or good afternoon or good evening if you are in other time zones. So my name is LAURENT POLIDORI. I'm the president of ISPRS Commission 3 Remote Sensing. And today it's my great pleasure to open one more webinar organized by Dr. Murali Krishna, who is the chairman of Working Group 9 of Commission 3, working group dedicated to health issues as remote sensing applications. Dr. Murali, you have organized many webinars so far, always with the valuable support of the ISPRS Student Consortium. So today with Nicolas Pucino. Thank you, Nicolas, for your support. And obviously, the topic of your working group around health issues has connections with land use, land cover, air and water quality, climate change, urban planning, and so on. And this is what makes your webinar so rich and interesting. So today, this is unusual because you will be one of the two speakers, and the other speaker will be Dr. Lidia Vitanova. So now I suggest you to introduce the objectives of this webinar. So if you want now, if you are ready, I can give you the floor to begin this session. So thank you.
Yeah, Dr. Nicolas, please use the speaker.
Yes, thank you so much for the initial remarks, Dr. LAURENT POLIDORI. It's a pleasure for me and for ISPRS Student Consortium to facilitate this for this time. And we'll just get into the webinar straight away. I want to present the first speaker of today. We have Dr. Lidia Vitanova. Dr. Lidia Vitanova is a senior researcher at the Gate Institute in Sofia, in Bulgaria. She will tell us all about herself during her presentation. And then the second speaker of today is, as you know, Dr. Murali. Dr. Murali is a distinguished academician and a researcher with a Ph.D. from the Indian Institute of Science, and was a former professor in geospatial technology and director, research and development at JN Tech University of Hyderabad, India. Currently is an independent researcher, entrepreneur, president of iSpace and Geospatial Project Consultant, and chairman of ISPRS Working Group on this Geospatial Environment and Earth Analytics. So without further ado, let's get into the webinar itself. Guys, I remember you to use the Q&A box to post all of your questions. We're going to go through all the questions at the end of the second presentation of Dr. Murali. Then that's pretty much it. Enjoy the webinar. Lidia, the floor is yours.
Thank you very much. Now I will share my presentation. Okay. Can you see the slide?
Yes.
Okay, thank you very much. First, I would like to say good morning, good afternoon, good evening, all of you. My name is Lidia Vitanova, and today I will present a presentation entitled Geospatial and Numerical Synergy for Urban Innovation, the case of Sofia Digital Twin. So before I start the topic, briefly I would like to introduce myself and also introduce our institute. Okay. So I'm from Bulgaria, Sofia, and actually my expertise is related to the ecology and environmental protection. And my PhD I took in Japan at University of Tsukuba regarding to the degree in geo-environmental science. And my doctoral topic was numerical study for urban heat island in Sofia and Sendai with present, past, and potential natural vegetation land use. So my expertise is multi-comprehensive because gather environment, gather some spatial analysis, and also mainly numerical modeling and study for urban heat island. So I have experience a long time in Japan as postdoctoral researcher, and from 2024 I am senior and experienced researcher in the GATE Institute in Bulgaria. So let me introduce about the GATE Institute. GATE Institute, it's fund from 2019. And actually, this institute is innovative institute in Bulgaria that is related to developing big data and AI, applied research, innovation, and education in collaboration with government, industry, and enterprises. So about the GATE Institute, maybe you can see here the map in Europe. So in blue color here down, this is Bulgaria. We are first data space innovation institute in the Eastern Europe. And also we have some domain which is related to digital health, to future cities, to smart industry, and to intelligent government. Here you can see this is the GATE Research and Innovation map. And also regarding to the bit research, we have involved in the data management, data analytics, data insight, engineering, and BD system. So more especially, today I will present several points. One of them will be the City Digital Twin pilot project we are involved on. And actually such a City Digital Twin is really important, not only for the Bulgarian Sofia, but I think beyond the world, in order to produce some high quality 3D model, to enrich, semantically enrich 3D model, to apply to the 3D model for simulation, analytics, and visualization, and also to promote the exploration of the digital twin. So in our institute, I belong to the future cities, and in our domain, we have several use cases. First use case is related to the urban planning and design. Another use case is related to the spatial temporal air quality analysis. Third use case is related to the solar potential analysis. Another is related to the wind and air pollution simulation. We also have research and experience in mobility and walkability, and my topic related to the climate, more especially urban heat island, heat risk, etc. Today, I would like to show some interesting use cases that is related to the urban heat island, and also to explain how synergy between several kind of approach is really important in order we not make some specific results, but also to make some data enrichment to some city and to have some important application for the city and citizens. Okay, first I would like to start. Maybe many of you understand and know what is the urban heat island. Actually, urban heat island, this is phenomenon which is the difference in surface air temperature between a city and its surrounding rural area. In many cities, actually in all the world, we have a lot of heat disasters. For example, urban heat island, heat waves. We have many kinds of disasters, but this phenomenon usually is appear in the city area. And when we have, for example, some increasing temperature base and due to the increasing anthropogenic heat, for example, in the building based on the air conditioning, heat from the building surface, we have some also heat from the vehicles. All such factors make importance in order to understand how they impact on environment, thermal environment in the city area. So about Sofia City. Sofia City, this is the capital of Bulgaria. Bulgaria, I already showed you in the map, is in the south east Europe. And here you can see Sofia City is actually surrounded by a mountain, is with elevation to 550 meters. And here in the right part, you can see this is the land use with red color. We have high residential land use, and with light red, we have medium residential, and with this little bit such pink, not only pink, but around pink, is a low residential area. So as you can see, Sofia have a lot of green areas, and actually is one of the most green city in Europe as capital, which makes Sofia very attractive and also important we to try to protect our city in order to not reduce more the green spaces. Okay, about uniqueness. Before we start to make some research, I think it's very important we understand the study area, the area we try to research, we try to analyze. That's why today I little bit have some intro regarding the Sofia, because many of you maybe, some of you maybe know about Sofia, but some of you first time hear about the Sofia uniqueness. So important thing for Sofia is that this is a city with very long history and very rich culture. So we have important things, variety of many kind of buildings. We have some concrete buildings, high-rise building. Interesting point, we have some complex topology also. For example, in the center area of the city, we have, for example, in this area, we don't have so high-rise building, but the most high-rise building is in the south part and suburb areas when it's new developing areas. Another important point I already explained, we have plenty of vegetation. We have also some transportation mixture. We have tram, trolley, bus, subway, which make our capital also interesting and a little bit difficult sometimes when we try to use and study about the mobility pattern. Also, this is based on connection between people and nature. An important point that Sofia is surrounded by mountain, and this make also very attractive in order to understand how connectivity to some special important points we have to determine. So what about urban heat island in Sofia? So some issue I would like to show, maybe you can recognize some of this problem in your cities that you are living or you are born. So important point for urban heat island, this is that climate change and seasonality based on urban heat island. Also, issue that is related to this phenomenon is increased energy consumption. We have a lot of building, and also some of the buildings based on the energy consumption and air conditioning increase energy consumption and lead to the increasing of the temperatures. Another thing is discomfort and danger to human health. Many countries, many cities during the hot season, they suffer from the heat stroke and some heat disorder. This also is some problem in Sofia and in Bulgaria, and also in the East and South Europe. Air pollution is another problem. More natural disaster. Many research already explained that based on the increasing of urbanization, natural disaster and some thunderstorm, for example, increase. And of course, least but not last, this is the biodiversity in danger. Another important point here that I would like to discuss before I explain our analysis and the result is what are the factors that influence urban heat island in Sofia. And maybe not only in Sofia, but in many cities you can face first a lot of heat generated by human activities, which rise the energy consumption also. Another big problem, this is the traffic increase. Also, we have in many cities reduction of green space and parks, increase of the urban development, and lack of water bodies. Unfortunately, poor urban planning and overpopulation is also some kind of impact of the increasing of the temperature in the local scale, and not only local, but also in the regional scale. We have some poor use of the common and unused areas, unfortunately, and use of inappropriate building materials. Also very important, this is influence of local climate. We always have to consider that cities is unique because they are located in some specific area. That's why influence of the local climate and topography is really, really important. And when we make some research, we need to consider this also a fact. And now we're going to the most important part. Here, this is the accent today. This is the geospatial and numerical synergy. I would like to explain why it's so important in order to make some urban innovation. So first of all, why it's important? Because combine some special context with some analytical power. For example, integrate some maps, 3D model, and location data with simulation and predictive models. Another important point for this synergy, this is support data-driven urban planning. For example, this enables city planners to visualize some test urban development scenario before some implementation. Another point important is that enhance sustainability and resilience. So, for example, some model energy flows, climate impact, urban heat islands, some resource usage in the urban context. Also optimize infrastructure and service. For example, this could help, for example, for some traffic, so some energy demand for the heat island, or some emergency, also some disasters that could be response in needs. And last but not least, this is foster innovation through interdisciplinary collaboration. So I think that usually collaboration is really, really important, because we are, how to say, we are a bouquet for a lot of flowers. Let's say every one of us is some flower with some experience and expertise. That's why when we try to make some interdisciplinary collaboration, I think this is crucial to develop together and bridge and make some bridge in order, for example, to get bridge in the geoinformatics, in AI, in engineering, in some urban governance, and in order to make some intelligent platform, in order to enrich the data, in order to create some nice visualization, etc. Okay, so I'm going to the next slide. And we starting now the main topic. First, I would like to introduce Urban Digital Twin, because today we will hear not only the Geospatial and not only numerical model, but this is actually our final purpose. So we try to develop some methodology in order to make some nice visualization, some innovative visualization, and also to enrich to the Urban Digital Twin. So first we have to understand what is Urban Digital Twin. So Urban Digital Twin, actually, this is the dynamic digital replica of the real world city on urban environment. And for example, this could integrate some 3D city models, real-time IoT sensors, simulation engines, some geospatial and environmental data. And also, such a digital twin also allows city, for example, to monitor some current condition. This could be some heat, traffic, pollution, and another environmental, and not only environmental, but some social lifestyle problem. Also to predict future scenarios, for example, energy demand, some flooding, hazards, and important to optimize urban planning and decision making. Why we need to interact actually the urban heat island and urban digital twin. This is in order to enhance data quality and resolution. This could also help to simulate the effect of different interventions aimed to reducing heat island. Important point is comprehensively to understand spatial and temporal variation for example, urban temperature. Here I give one example. For example, we have 2D heat maps, which effectively display some spatial distribution of air temperature, land use, anthropogenic heat, and other surface level factors, and also to allow for easy identification of hotspot and extend urban heat island. And also important thing is to understand some specific points of some phenomenon. For example, for the urban heat island, this is the contribution of the urban canyon to temperature variation. And now we go to the next how. And first, how we did this actually pipeline and this way, this storyline. I would like to show first what we have done by some interesting examples. All these examples we already have it published. Maybe after that you can contact me. I will share the QR code. I can share more information about the paper and the methodology and our result. So first thing we have done, this is the preparation of the energy consumption map. Before we calculate some, let's say when we focus on some problem, it's heat or any whenever what is, we need to understand what kind of data is needed to be gathered and collected, and what data we need to analyze in order to visualize, in order to simulate that, some specific phenomenon. In our case, this is very important, from high importance. This is preparation of the energy consumption map. So first I would like to introduce, this is the first study case. We make the first energy atlas in Bulgaria and in Sofia related to the energy consumption separated by different kind of buildings. So here, very briefly, I would like to show you, we use some kind of interesting multi-comprehensive methodology. So the study uses a methodology based on GIS and tolerance statistic to estimate building energy consumption and develop the atlas. So the development of the atlas is based on several steps. So first we have some data collection, then we have GIS classification. In the third, we use the tolerance analysis. In the fourth, we create energy consumption scenarios. In five, we develop the visualization of the energy atlas. Actually, for GIS classification, we have some sample areas of the building, energy consumption building, from several groups: administrative, cultural, healthcare, hotel, kindergarten, residential, retail, school, sports, university. And this building for us was key point because based on this samples area, we could estimate by tolerance analysis the energy scenarios and develop the visualization of the energy atlas. So in the next slide, you can see first this is the all image of the energy atlas of Sofia. This is the 2D distribution of the high energy scenario. We have high energy and low energy scenario. And you can see here in this map the clear contrast in energy consumption between building in high urbanized area. This is usually the central area, commercial area, industrial area, some sport building. For example, here also we have some high cluster that represent the commercial area. Also, a presence of many buildings with a large floor area, high-rise buildings, also impact to the increase of the energy in Sofia city. And application of the research, here you can also see in the QR code you can scan if you're interested. We have enriched to our 3D city model with just one area. This is the Lozny district, very green area in Sofia city. You can see here we have a high energy scenario and low energy scenario by the buildings. So the red color and the dark red show some high energy consumption, and yellow color shows some low energy consumption. When we click to the building in our platform, for example, we can see, let's say, the height of the building, what kind of the building this is, what is the function, longitude, latitude, depends also what is the energy, high energy or low energy. And also in the current platform, we also have developed the temperature that can be a temperature based on the energy consumption of the buildings. Next, what is the next base? We already gathered the energy consumption data, and we try to gather more data in order to perform our simulation. And another things we have tried to do is to assess understanding urban heat island through the urban digital twin. So very briefly, this is the workflow of the study. I will not explain everything, but important point, we will gather several kind of the approaches regarding to the urban heat island, to the 3D city model, some common workflow steps, and here we show some important main paths for the urban heat simulation and integration of the obtained result to the 3D city model. So the blue boxes correspond to the urban heat island simulation steps, the purple box explain to the 3D city model enrichment steps, and green box is the common steps. So first of all, this is actually this map showing, actually this is the this is simulated result. We use regional model, weather research and forecasting model. Here, this is a result with a 250-meter resolution, and you can see the urban heat island in 9 o'clock p.m. This is in Sofia area, and also we don't have clear urban heat island in the 4 p.m. in Sofia city. Important point here is that you can see here we have more than 6-degree difference between central areas and suburban areas. But looking this to the map, we cannot see very well actually what is the connection with the building, what is the connection with the street canyons, what is the connection with the greenery. So here we would like to show you how one 2D map by our model look like. And actually, we cannot make some correlation looking this to the map. That's why our purpose is we try to actually to make some data enrichment and make better map in order to show people better the problem. So going to the next step, data enrichment to the 3D model. First, we use GIS actually to extract only the city area. Here you can see we don't have surrounding temperature. Here we can have completely same map that you already saw in the previous slides. But now you can see very clear that we have some, for example, in the 4 o'clock in the previous map, we didn't have any kind, maybe I can turn back to see again. Here, if everything, we even we make some special temperature step, very small. We don't have we cannot see very well the temperature distribution. But when we extract the data, actually here we can see some hotspot in some specific neighborhood level areas. So first that we extract this data. We actually make only the data for the Sofia city boundary level, and the data I already explained. This is 250 meter grid spacing. Next step, which is, I think, very important. This is the integration of the 2D urban heat data into 3D city model. So here you can see in this left part, very beautiful become our map because it's based on the building. Already we make this based on the building. Important point here is that this temperature is actually not temperature of the building. This temperature is 2 meter temperature under the building. But in order we show more clear to the publicity, to the community, we would like, for example, in such a platform to click on the building, and we wanted to see, for example, what kind of temperature there is in this area, what kind of energy there is consumption. And actually this is the way how the digital twin works. So in order to integrate this map, we make some data conversion. I will not now explain all this step, but just for your understanding, we make some raster surface creation, calculation building footprint, and also we make some 3D building visualization in order to make this map. And in the next, here you can see all cities, Sofia city. Maybe you can, here you can scan QR code. You can see also our platform in the 9 o'clock and 4 o'clock in Sofia city. So we can you can see here very easily the urban heat island in the central area. Here we have the temperature. If you go to some building, you can see some, for example, already some temperature, and you can see also some energy consumption by the building. And here is another map in the 4 o'clock. Here, as already explained, we don't have urban heat island in the central area of the city, but we have some hotspot, let's say, in the neighborhood level. Maybe some of you will ask why we have increasing of the temperature in some specific area. This is because first of the land use, depend on the land use category. Second, this is because of the energy consumption by building. And third, this is also depend on the urban density. In area, we, for example, we don't have, just a second, yes, sorry. We don't have, let's say, so many green area. Usually we have increasing of the temperature compared to the another areas. And also you can see here in the suburb areas, when we have plenty of vegetation, we have reducing the energy consumption. We also have reducing of the temperature around 3-4 degrees compared to the central area. And here you can see we can zoom on some for example, problematic areas. And for example, this is central area in Sofia, especially in some shopping center, some corporate center, hotels, some open space that is covered with asphalt and concrete. And we can see the temperature increase by more than 1 degree compared to the surrounding area. And in 4 o'clock, the temperature range between 27 and 28 degrees that indicate not so strong heat island, especially in that hour. And I'm going to the, this is the last slide. This is the application of the research. I already explained that such a synergy between several kinds of the approaches and methodologies is really important in order we gather scientists, we gather some experts, and actually such approach is important in order to provide some decision making, not only to the government, but also to provide some knowledge and to provide some service to the business, to industry, and also to make more visible for the citizenship. So we try to gather all these stakeholders in order to show them, for example, what is the approach, how we can get to this approach, and what could be the solution if we provide to them such analysis and results. So here I have just explained that application is to understand, to provide, to support, to enrich. More important, for example, to understand some connection between energy consumption and building and traffic, to understand how the impact of some heat and thermal environment could affect on the local climate and urbanization, to provide some visibility and understanding of the current energy trend by creating some energy atlas or some updated or innovative visualization, to support creation of the cost-effective energy and climate change measures and policy, to enrich already explained 2D and 3D model with essential information regarding the energy consumption and some urban heat island distribution, and to support decision-making and facilitate application of the smart technology related to the climate change and urban heat island. This is my motto: let's make science together, because I think science is such an art. So if you have any interest or you would like to interact with me, you can find me in this email, or also you can scan the QR code to my LinkedIn, and I will be very happy to connect with you and have a discussion. Thank you very much for your attention.
Thank you. Thank you so much, Lidia. The presentation was amazing. I liked also the QR code with the 3D application. I tried it and it works. There is a lot of data. Good stuff. Okay, questions. Please post the questions in QA chat box. I remind you. Let's move with the second presentation of today. Dr. Murali, please. You can share the screen. Thank you, Lidia, for unsharing. Dr. Murali, you can share the screen and start the presentation when you're ready.
Hi, are you getting my screen?
Yes, yes.
It's okay?
Perfect. Thank you.
So, again, greetings to all. I'm the second presenter of this today's webinar on this topic of entrepreneurship opportunities in geospatial technology applications. Essentially, today, particularly in my personal opinion, there is no place in the entire space sector with more opportunity right now than the intersection of the satellite Earth observation data and industry and the geospatial industry. And we have a rich set of data. It is in this particular context, what is the things happening at this point of the time, and how the passionate people who are looking for startups, entrepreneurship opportunities could utilize the geospatial technology. So my specific focus is, when we say the satellite space technology entrepreneurship, they mostly concentrate on what you call as the satellite technology, launch vehicles, development of sensors, etc. But not many startups have come on the application of the data towards sustainable development goals and address the problems of earth, environment, and people. So considering these things, what is the way forward is my question. So we cannot solve the problems by using the same kind of thinking we used when we created them, as Albert Einstein says. So we need innovation in these things, and one of the most important aspects here is the design thinking, ideation, testing, innovation through empathy. These are all many of the people quite familiar with the design thinking. I just want to only re-quote the importance of design thinking, but which is not a product or a process. And ultimately, how it's happening in this today in terms of development of technology. Technology is developing very rapidly, while productivity is going very, very slowly. So what is the issue? Why so in an exponential world, why are these things are happening? So we need some sort of a addressing the problems of the people in a much more human-centered manner. And that is what exactly you wanted to specify here. See, for example, there are tons of solutions to solve a single problem related to earth, environment, and people, which is a real world problem. It could be. But how about a single solution that solves tons of problems related to earth, environment, and people, real world problem? That's what Dr. Lidia Vitanova has identified today, mentioning about the urban heat islands and the environmental concern. So this is where, what is the single solution? I'm not, arrogant. I'm more confident when I say that the geospatial technology has got a single solution to address several tons of problems related to the earth, environment, and people. So ultimately, the geospatial technology in terms of what is things happening is very, very significant, because the addressing the taking advantage of the satellite imagery, earth observation is one of the major significant example of the geospatial field, which has got good synergy with the space exploration industry. So the ultimately, the geospatial technology has got a huge potential to address various issues, and where exactly things are happening, we can see here significantly. So I just wanted to, I'm not going to address all these issues, but let me say what are the key steps for launching a startup or entrepreneurship. First one is very important. I will just handle only the first one. Remaining things can be automatically followed up by adopting any typical business model. Idea validation, because research and validation of your business idea to ensure there is a market need and demand. That is what exactly is one of the very, very important specific things where we have to address the issues in a much more significant manner. So here the people say, when we entrepreneurship or a startup, technology push is dominating in many places than the technology pull. So whatever technology I know, I just start entrepreneurship or become an entrepreneur or go for a startup, but which may not have meet the needs of the society, may not meet the needs of the the government, may not needs the requirements as on towards the sustainable development goals. While doing these things, the most important component is the technology pull. How the technology is pull happens is, whatever technology that is needed, what are the problems that are needed, if you can apply the technology towards that, then the startup, the entrepreneur can get immediate market. That is what exactly is happening. Many times a very passionate technologist opens a startup and looks for the market. That is a totally wrong concept. So I always adopt the principle of technology pull, what is needed in the society, what are the problems need to be addressed, and develop the technology and go for a startup that will have immediate marketing need. So marketing facility ultimately. So that is what exactly I'm going to say is the technology pull is always important than the technology push. So ultimately, what is happening here is few ideas. Let us talk about it, because the geospatial technology which is encompassing GIS, satellite data, location intelligence, which is very important, which is offering a very, very, very vast amount of what you call as opportunities for entrepreneurship across different sectors. So your ability to analyze or interpret the data based on the location provides some of the unique opportunities for any of the innovative startups. While doing these issues, one example I say is agriculture. Today, precision agriculture and smart farming solutions, particularly in the era of deep tech era. In deep tech era, the smart manufacturing is one of the key factors because of the application of the tools of AI and associated products. So a particular application of precision agriculture startup which can ultimately offer many services to the farmers with some sort of details like what is the crop health, what is the soil condition, what are the moisture levels, and what is the happening with the pest detection, and how the drone imagery and analysis could be carried out. And this particularly operation can lead to optimized fertilization and utilization of the water, that is irrigation, and also forecasting of the yield. So which has got a very good entrepreneurship opportunity, particularly in precision agriculture and smart farming solutions. So entrepreneurs can offer specifically services with detailed insights, as I already telling about these factors. While doing these specific issues, the other aspect is the environmental monitoring and conservation, because the climate risk assessment is one important aspect, resource management, because developing some sort of what you call as tools for example, take deforestation or monitoring wildlife problems or managing the water resources and planning some sort of a sustainable land use are some of the significant aspects here, which has got enormous potential to utilize the technology, provide the solution, and sell the solution and make a good business model out of these things. So disaster management is one aspect, the logistics, etc. They happen to be some of the very, very significant models over a period of the time in many, many issues. Basically, what happens here is the important aspect is related to utilities and infrastructure management. Well, these are the issues that has need to be addressed specifically while taking care of the issues of satellite technology and integration in the geospatial domain. So the other aspect is the public health and public health management. Ultimately, the disease mapping, some sort of a outbreak tracking, and other developing some applications to visualize and analyze the spread of the diseases, or otherwise identify the hotspots, and also assist in resource allocation for some sort of public health facilities, along with the healthcare facility planning, happens to be one of the very, very significant developmental programs. Here there are very important, significant case studies carried out in Zambia under the national, what you call as, I think it is a Malaria Elimination Center, which has integrated the GIS technology and enhanced its the product, etc., along with the high resolution data, and provided for about more than 100 districts GIS-based maps for planning and providing solutions on the tip of a button. And ultimately, this has provided a good amount of success as a startup in Zambia. So the world is drowning in data. So most important thing is the world is drowning in data, and ultimately, whether you are talking in a spatial context, whether the data is connected or disconnected or incomplete or misleading, there is where the GIS is providing, the geospatial technology is providing the missing link between the data and the required solution. So the geospatial technology here plays a very, very significant role, and the data that is available could be utilized in a much more meaningful manner by appropriate innovative methods and addressing the tools of design, applying the tools of design thinking and addressing the needs of the society. Those are the very, very significant aspects that need to be addressed. There is no digital transformation. That is what exactly it says, because there is no digital transformation without geospatial intelligence. So let us understand here, the tools are very powerful, and what you need is the spatial mindset. What happens is the data is available, the models that are developed in one part of the globe cannot be applied to the other part because this is a spatial data. It is linked with the ecological, environmental, agroclimatic situations. And what is important is the spatial mindset, which unlocks the value of this data. So let us say the critical thinking and the creativity and willingness to adopt appropriate methods as the very, very significant aspects for any developmental programs. While doing this, let us understand geospatial technology is no longer just a tool or a language, but a path demanding spatial thinking. Spatial thinking is one of the very, very crucial elements, because I was telling the geospatial knowledge, the algorithms, the technology that is developed in one part of the environment may not be applicable to other parts of the environment. So that means spatial thinking is crucial because it allows you to understand and also analyze and also reason about the objects and phenomena, whatever phenomena what you are having in terms of its location and distribution and the pattern and the relationship in the global situation. So it is a fundamental cognition skill that is needed for any type of applications ultimately. So that is where we are talking about the spatial thinking, geospatial entrepreneurship, the deeper problem understanding, as well as enhanced data interpretation and analysis are the very, very crucial elements in this particular effort. So spatial thinking is, as I was telling, is very relevant and crucial for geospatial entrepreneurship because it involves in the visualization, interpretation, and reasoning about the location, distribution, patterns, and the relationship phenomena on Earth. So for example, for any geospatial entrepreneurs, this means you are being able to identify appropriate market opportunities, and you can optimize your logistics for implementation of a product or a process or a customer satisfaction or a business model. So ultimately, the unlocking the very, very important aspects of the geospatial data happens to be the significant aspect of the geospatial environment. Ultimately, when we are talking about these aspects, where are we, how are we, matters a lot, because in a sense, the spatial thinking is one of the very, very cognitive framework. I call it cognitive framework, which allows you, the geospatial entrepreneurs, to conceptualize, analyze, and solve problems using the power of this location. That is what is important thing. It is not just about knowing what you know about GIS, etc. But here the location makes all the difference. One of the important components, contributions, allows you in a very productive manner. So we are addressing some sort of, let us say, a public health domain is one aspect which we are talking about it here. And while we are talking about these issues, the public health has taken a case. The opportunity involve leveraging cutting-edge technologies like artificial intelligence, etc., etc. So many startups in this space collaborate with established companies so that they can get component facility for research and also the government agencies to develop and scale the solutions. While doing these aspects, and essentially, where are we, what is happening, and what are the examples case studies that have happened in as a startup industry. So decision making is one of the issues. I will not talk more about these things. Today, large language models have come up as a great asset, which is a type of artificial intelligence that can mimic human intelligence, which has got a very, very significant role in identifying, starting from spatial thinking to ultimately optimizing the product or the process delivery in terms of the achieving the sustainable development goals. Talking about these issues, well, thinking that the geospatial technology is offering a vast and growing landscapes. So ultimately, I don't want to read all those issues which I'm just mentioning here, which may be useful even when at the time of after the recording. So thanks to the advances in the data, the deep tech along with the location intelligence is playing a very, very significant role, and our ability to analyze, visualize, and interpret data based on the location provides a very significant unique opportunity for any sort of innovation startups. While talking about these issues where we are happening, one important case study here is what is given in the Jim International magazine, which I happened to read a couple of weeks back, is developing good earth observation methods to provide environmental insights for sustainable impact with focus on deforestation, reforestation, carbon diversity, etc. So ultimately, this is one of the innovative geospatial technique to solve the geospatial global sustainability challenges, which may be referred in the latest Jim magazine, Jim International magazine. Then the other example I am giving from India is a public-private collaboration has been happened between ISRO and the private company, and the startup, it provides the startup incubations and support, and with focus on identifying and nurturing promising space technology startups in areas like geospatial technology, enabling technologies for space and mobility. So these are some of the issues which could be utilized by the startups, by the national space organizations, infrastructure. There are many countries have got national space organizations. That infrastructure could be utilized. The resources can be utilized for product design, testing, IP management, and market strategy. While these are the examples that have been identified, there are other developments, because these are polar orbiting satellites are there, low Earth orbit satellites are there, and today the low Earth orbit satellites are providing great opportunity. It is exciting to see the developments in the sector of CubeSats, because these CubeSats, which roughly about 10 centimeters by 10 centimeter cubed items weighing about a kg, have revolutionized the entire space due to the numerous advantages it is providing compared to a polar orbiting satellites in terms of affordability, or in terms of getting information in a faster manner, and opportunities for launching, and also the potential of the constellation, and in also the technological advancements, the experimentation, and the value it is providing is significant for any sort of applications. Because today the most important problem the entire globe is facing is the climate change, disaster risk reduction. Climate change adaptation, disaster risk reduction requires focused data at regular intervals, which will be very expensive using polar orbiting satellites, but a consortium of the CubeSats provides the information in a much more meaningful manner. So, for example, the climate change I was telling here, developing methane emission monitoring is one important component. Similarly, you can think about the forestry and deforestation tracking, glacier monitoring, coastal erosion, atmospheric composition analysis. These all the products, processes, customer satisfaction could be incorporated in a business model in the type of an entrepreneur can collect the data and feed the appropriate intervening organizations the right methods, right models, right warnings. Exactly the urban heat islands, as explained before this by the speaker before me. So these are the challenges that could be met using the providing the entrepreneurship opportunities in the CubeSats is one important aspect as I see. So this is what is already I was telling about urban heat islands, population density, precision agriculture, and soil moisture, land use, land cover mapping, agriculture insurance. This insurance is one of the very important sectors today, looking for a lot of information, which has got a great potential for entrepreneurship, because the insurance company needs data on all aspects impacted by the climate and disaster, and geospatial technology can provide real-time effective solutions in a very efficient manner. Ultimately, this happens to be one of the most significant entrepreneurship application of geospatial technology will be insurance sector. While talking about these issues, we are talking about the CubeSats data, which providing orbiting satellite data for startup launching and entrepreneurship development aspects. While doing these things, the CubeSats, as I was already telling, give you data very fast, and it's got the polar orbiting satellites require too much specialization, whereas the concept of CubeSats, proof of concept and validation is under progress, and this has got exact output on par with the polar orbiting satellite, as could be understood by several developments that have taken place. So let us note that polar orbiting satellites remain essential for global long-term monitoring. I'm not saying by CubeSat you are going to replace the polar orbiting satellites, but the synergy between these two provides, whereas a long-term monitoring by the polar orbiting satellites, quick monitoring by these CubeSats provides a distinct advantages for startups to enable some sort of agile development, a collection, and also rapid iteration, and significantly enables every entrepreneur to enter the space segment and fosters a sort of a dynamic, innovative entrepreneurial landscape in the space industry. That is my vision as I see the application of geospatial technology. So it can be seen, so many companies have already come up in Canada, in Germany, in Finland, in USA, and Italy for climate change protection. So very good entrepreneurs are already working in this area. And for agriculture, Planet Labs is one of the very powerful CubeSat mission, which has got readily made available data for anybody to be innovative, use the data, develop a model, and launch a startup using the PlanetSat data. So precision agriculture, yield prediction, agriculture insurance, there are the three important components that could be addressed through this effort. So it is worth noting some of the Indian companies also are there launching, the companies like the aeronautics, the startups, Dhruva Space, and also small satellite antennas, etc. So we are looking into the many companies, satellite technology and applications, various efforts are being made while doing these specific methods. What is happening, where is happening, ultimately happens to be very significant aspect for any sort of developmental effort. Because the example of Planet Labs is exciting. Anybody can go through the Planet Labs example. That happens to be very significant because it is one of the most successful stories in CubeSat is the planet operates in a very large constellation of the Earth observing satellites. While doing these particular issues, what is happening, where are we, etc., those is very significant developmental effort. So while entrepreneurial operations in emerging areas require special skill, I believe that one should strike a balance between the entrepreneurship side and the technological innovation side of the business. So entrepreneurship is one aspect to make a business, and technology is innovation. So whatever technology you know may not get you good returns. So ultimately the concept of design thinking, you have to use the design thinking as a medium to address the technology needs. It's the technology pull, not technology push. That is the catchword. And if you are a potential entrepreneur, educator, please understand your geospatial technology into business intelligence. You have to integrate and also think spatially. Spatial thinking is very, very important, and also technology pull, but it's the shortcut for success, not technology push. When I say technology push, don't open an entrepreneurship, a startup with whatever technology you know, which may not have any demand, and you ultimately fail. So basically, let us use the technology which is needed by the society, which has got great demand in terms of applications. While doing these issues, where we can see enormous opportunities are there in the geospatial technology domain. Thank you very much.
Perfect. Thank you so much, Dr. Murali, for the inspiring presentation. I'm looking at the audience now. If you have questions, please post them in the QA box or in the chat now. But I don't see any question for now. How long do you want to go? Usually it's 1 hour, 1 hour and a half.
It's okay. 1 hour is enough.
Okay.
If there are no questions, we can close it by thanking the speakers.
Yes, if you, yeah, I don't see any question for now, but if you have questions for later for the audience, please look in the chat. There is the email of Dr. Murali and also the LinkedIn contact of Dr. Lidia Vitanova. So you can find their contacts in the chat.
Yeah, Nicolas, I just want to, specifically thank Dr. Lidia for some of the very important 3D city model and identifying very critical issues like the high energy scenario, low energy scenario, and the energy consumption in terms of, I'm just recollecting what has been told, and ultimate integration of this into a 3D city model visualization is a very good effort that has been made by Dr. Lidia Vitanova. Thank you, Dr. Lidia. So I will handle this.
I just wanted to thanks also to all of you and Professor Yankee. So just I would say that I also thanks to my colleague from Gate Institute, because actually we have group and such research is made by me, but also by my colleagues. And thanks to them also we could it to make. And I would like also to thanks to Professor Yankee also for the very interesting presentation. Actually, this CubeSat is really interesting and very, I think it's really innovative in many countries. And I'm thinking that in my country also we try to make such a satellite, and they are very, I think it's future because they are small and they are compact, they can be easy. And just I have question to you, how do you think you show some very interesting example in India and also in other countries? How do you think another approach, not only CubeSat, do you know something that could be useful for measurement or for something that could be also low cost in some way? Another example for the, used for the academic reason, but could be also used for the business reason.
Yeah,
Is
it's
my
an
question.
interesting question. So it is a continuous process. Development is a continuous process in terms of reduction of the cost, improving the technology ultimately. But the low Earth orbit satellites, the CubeSat, etc., have come as a compromise. And this data is available today. 10 years back, satellite data somebody has to buy. Today, the data, CubeSat data, the sample data is available from Planet Lab, and they provide the data for education institutions. And I have guided 2 PhDs using the Planet data. So there is enough scope for all these things. And the only thing is spatial thinking and willingness to do, and technology pull, not technology pull. Technology pull is what is needed. Ultimately, identifying the technology, what is needed towards sustainable development goals. And that makes any entrepreneur, any scientific effort, any researcher good success. Thank you.
Yes, thank you very much. I totally agree with you. And actually, I totally agree that everything should be considered in all stakeholders when we try to make some research or when we try to make some approach, methodology, analysis, product, etc. So I agree completely with your concept. Thank you very much.
Yeah, There are many climate change programs from Canada, and Carbon Mapper from US is providing good information.
Yes.
And they from the US, other one New Zealand, I think they are doing some methane sat. So there are a lot of things, and the future is going to be monitoring the climate change, disaster risk reduction, and it requires as big the Earth. We need so many sources of the data, both in terms of the spatial dimension as well as the temporal dimension. That is what is the geospatial technology is the answer for these things. Thank you. I think that's finished.
Yeah. Thank you very much.
Okay. If there are no other questions, maybe I have one quick question for Dr. Lidia Vitanova. It's about your product, the 3D visualization. And just a question about how often does the data get updated? Is it a live service that you offer, or it's how does it work?
Yes, thank you for your important question. It's not a live service. This is just such a trio. We try to produce some live data we have for the air pollution, actually. For the heat, we don't have. Actually, for heat is very, I mean, there's such a weather prediction we didn't make, but actually we have several platforms in the Gate Institute that we have such data. Also, I forgot to explain, we have sensor data. This sensor data, we try to measure some kind of the not only heat, but also we try to make some walkability research. But for our study, this data is simulated data, and unfortunately, it's not real data. But even not real data, I think they can provide very good knowledge regarding to the problem. Where is the problem, for example? And if we know where is the problem, maybe we can focus in more detailed area in order to develop and make some solution for this area.
Okay, thank you.
Yes, thank you very much. But we try to improve our digital twin because this is such a tool should be always developed and always to work on. So I think in future, maybe I can show you some updated, interesting results, not only for the heat, but also for another kind of the urban problems.
Okay, thank you much. And there is a question for you actually that just arrived
Yes.
on the chat by Eftimios. Thank you so much, Eftimios. He asked, why is useful the data and measurements? Basically, are there geo collaborations at the governance level?
Of course, all collaboration, not only geo collaboration, I think it's usually very useful because we try to interact with different kind of approach, because all kind of the, not only geo, but numerical or some, let's say statistical analysis or something, we have always some pros and cons. And in order we try to develop something, or we try to remove some gap, I think we always have to collaborate. And in governance level, of course, there is such a way. So that's why it's important. Just this is general answer. I hope I could answer to you, to the Eftimius. But data and measurement, actually, data and measurement, I think it's this is the basic thing in one research. If we don't have data, or some measurement to make the data, to have a data, we cannot proceed to the next level. That's why in today's presentation, I already show that data gathering, data collection, data processing and pre-processing, it's really pre-processing and processing. It's really important when we try to see some problem, or we try to make some analysis, or we try to make some visualization.
Thank you,
Thank you.
Dr. Lidia Vitanova. Okay, I think it's yes. Thank you so much. Eftimius says thank you.
Thank
If
you.
there are any other questions, maybe Lauren, if you want to say something else. No, all good.
Laurent will conclude it. Dr. Laurent may conclude it.
Okay.
No, it's just a thank you because it's once again very interesting. So thank you and have a good day or night.
Perfect. Okay. Thank you so much, everyone, for
I have
this.
one question. Sorry, last question. The presentation.
Go.
So this presentation could be available, or also about the link for this event. Could you please share later, or I don't know how in some way.
They'll send the link, I think.
Yes. The presentation is all the webinar is recorded, and we will be publishing it on YouTube on the ISPRS Student Consortium YouTube channel. As soon as it's published, me or Lakshmi, usually Lakshmi, our president, will get in contact with you and send the link, and you can share it wherever you want.
Thank you very much.
Okay. Thank you again for this webinar, very informative, inspiring, and I'll invite all the attendees to keep on following our updates for the following webinars and get in touch with ISPRS and ISPRS Student Consortium and the researchers here. Thank you so much. Have a nice day.
Thank you all. Thank you all.
Thank you. Thank you for
Bye.
attention. Bye-bye.